Hello everyone, welcome to this video. In this video, we are going to cover some properties about the parallel lines and what is the transversal. And later on, we will do some properties combining both of them. So first of all, let me revise you about the parallel lines. So it's written there that two lines in a plane are said to be parallel if they do not intersect how far they are extended in both directions. As we already did this thing, so I can directly give you the example that this line L and another one is M. They are parallel only when if we extend both these lines like that and they never intersect each other. Okay, this one is for the line L. Now let me extend the M also. So you can see they are not intersecting. Okay, so in such a case, we can say the both two lines are parallel. Now some its symbol also given there. Suppose if line L is parallel to M. So instead of writing this complete sentence, we can directly say L, two straight line and then M, which means L is parallel to M. If we draw, this one is L and this one is M. So it represents that L is parallel to M. For example, opposite edges of rectangle and railway tracks as done already. Okay, so I'm drawing one example. It's rectangle, then this side and this side are parallel to each other. Now the main part of our video starts from there, which is transversal. Okay, so it's written there, a transversal is a line that intersect two or more lines at a distinct points. For example, this one is line L and this one is line M. So if we have any line like this, suppose it's N, then we can say it's intersecting L at this point. Suppose its one is O1 and also intersecting M at different point O2. We can say O1 and O2 are different points. So in such a case, we can say N is traversal or transversal. Okay. So let me give you a condition in which most students are confused, which is not transversal. Suppose this one is L and this one is M, and for this line N, we can say N intersects both L and M, okay, at the point O, which is there. But this is the same point, so we say N is not transversal. The only condition is that the point should be different, okay, distinct, which is in this case. So it's the transversal. So let me read all the other things. So if the lines cut by transversal are parallel, several angles are formed. Okay, now some special case. Suppose the two lines, which are this one. First one is L and this one is M, and we say the N is transversal. Okay, N in this case is transversal. So when L and M are two parallel lines, then there are some special angles formed and they have some relationships. So now this topic we are doing for the case when transversal intersect two parallel lines at two different points like that. Okay. So when a transversal cuts two parallel lines, the following pairs of angles are formed. So first of all, the first one is corresponding angles. Okay, so let me name all these angles so it will be more easy for you. Suppose this one is angle 1, this one is angle 2, this one is angle 3, this one is angle 4, this is 5, 6, 7, and the last one is 8. So corresponding angles, it's written there for this, they lie on the same side of the transversal, one interior and one exterior, which means they lie on the same side of transversal. So we can say angle transversal is this one, N, on same side, which means 7 and 6, 8 and 5, 3, 2, 1, 4. It's also written there 1 and 5, 2 and 6. So we can say angle 1 and angle 5 are corresponding angles. Okay, which means angle 5 is on the right side of transversal. This is our transversal, angle 5 is on right side and 1 is also on the right side. But 5 is interior and 1 is exterior, which is written there. So they are the corresponding angles. And in the case when two lines are parallel, corresponding angles are equal, which means we can say angle 1 is equal to angle 5, angle 4 is equal to angle 8, angle 2 is equal to angle 6, which is written there, 2 is there, 6 is there, 4 and 8. Now can you tell me, is angle 3 is equal to angle 7 or no? They will be equal because they are parallel lines and both of them are corresponding angles. Now the second one which is written there, it's alternate interior angles. So lie on the opposite side of the transversal, which means suppose first one is in left direction, then the second one will be in the right direction. And alternate interior angles are equal. So first of all, we have to write the pair, alternate interior angles. Okay, so the 3 is interior there and 5 is also. They are of opposite sides. So we can say angle 3 and angle 5, and the another pair angle 4 and angle 6 are pair of alternate interior angles such that they are equal, which means angle 3 is equal to angle 5, angle 4 is equal to angle 6. So that's for alternate interior angles. Now the third one is written there, alternate in exterior angles. Okay, so I am using the same figure. So it's written they lie on opposite side of transversal both outside two lines, which means this angle is outside, this one is also outside, 7 and 8. But condition is that if 2 is in the left direction, then we have to pick 8 which is in the right direction. So example for that will be alternate exterior angles. I am representing this by AEA, and if we look into the figure, it's angle 1 and angle 7. This is 1, this is 7. Angle 1 and 7, and both will be equal as the alternate exterior pair is also equal. And angle 2 and angle 8 also. This one, angle 2 and angle 8. So another pair is angle 2 is equal to angle 8. So now the fourth one, it's interior angles on same side of transversal. Okay, so let me draw another figure. Otherwise it will be confusing. Here M is parallel to N, L is the transversal. So these angles which are on the same side of the transversal and interior, so their sum will be is equal to 180 degree. Okay, interior angles on the same side of transversal, like co-interior or consecutive interior, which means this pair and next pair will be this one. Okay, so their property, they are supplementary, and we know supplementary angles are the angles whose sum is 180 degree. So we can write this angle is 3, 5, 4, 6, 1, 2, and this 7, this 8. So we can say angle 4 and angle 6 are interior angles on same side, and their sum is 180 degree. Okay, and same happens for this one, angle 3 plus angle 5 is equal to 180 degree. It's also written there. Now some important results are given, which we have already did. So first one is that if two parallel lines are cut by a transversal, then corresponding angles are equal, which means angle 2 is equal to angle 5. They are corresponding angles. This pair 1 and 6, 3 and 8, 4 and 7, they are equal. Alternate interior angles are also equal, which means angle 4 is equal to angle 5, angle 3 is equal to angle 6. Now alternate exterior angles are equal, which means angle 2 is equal to angle 7, angle 1 is equal to angle 8. Now interior angles on same side are supplementary, which means angle 4 plus angle 6 is equal to 180 degree, angle 3 plus angle 5 is equal to 180 degree. So you have to revise all these concepts, because if we don't revise, then it will be confusing. Now the converse statement. If a transversal makes of these conditions true, then two lines are parallel, which means if we have given two lines, this one is M, this one is N, and this is the transversal L. We don't know M is parallel to N. Okay, there is no such data. But if any condition like 1, 2, 3, 4, and any this point is true, then we can directly say M is parallel to N. For example, if this angle is 1 and this angle is 2, and if I say angle 1 plus angle 2 is equal to 180, then we can directly say M is parallel to N. Or any other property like this one, this, if any property is satisfied, then we can directly say M is parallel to N. Now the last part of this video, it's written there, lines parallel to the same line, which means suppose this is the line and it's L, and the another line which is M. Suppose we have one more line, this one. Okay, suppose there are three lines and their name is L, M, N, and it's given that M is parallel to L and M is parallel to N, which means M is the single line which is parallel with this one and this one. So according to the condition, we can directly say that lines which are parallel to the same lines are parallel to each other, which means if M is parallel to L and N, so we can directly say L is parallel to N. Okay, that's the point of this line. So I think all the points we have discussed in this video are clear to you. So keep practicing and do study. Still, if you got any doubt, then you are free to ask me using my Urban Pro profile. So thanks to you.